Hi guys, welcome to Code Decode. In this video, we'll be looking into some very commonly asked TCS interview questions for Java developers. Please like, share and subscribe to support us so that these videos reaches to more of the people who are preparing for interviews like you. First, we'll see what are the features of Spring. Being a Java developer, even though if you're using Spring Boot to create your applications, Spring will remain integral part of your daily life. So you must know the features of Spring. So let's see some features of Spring given to us to make our life easy. First is inversion of control. Spring's inversion of control says that invert the control of creation of objects from developer and application to the framework. So with inversion of control of Spring, we give all the control of creating and managing the life cycle of a bean from developer and application to the Spring container. And why do we do that? This promotes loose coupling, more modularity and maintainability. And that's the best feature given by Spring to us, which removes most of our headache to manage the beans by ourselves. Now, IOC was a principle. How to implement IOC in Spring is dependency injection. So dependency injection is a way to implement inversion of control, which actually allows you to inject the dependency of one object into another, thereby making our application loosely coupled, more flexible and easy to test. Thereby also making sure that we are not going to lose any of the bean if the parent bean is destroyed, because all the beans are independently created and managed by Spring container for us. We do not create any bean as a part of any parent. Third important feature given by Spring is AOP. We must have used this here and there whenever we will be implementing the cross-cutting concerns like logging, security, transaction management. So AOP basically allows you to segregate the cross-cutting concerns like these from the business logic. Fourth is, now since you are working in an end-to-end enterprise level application, you always need a database to handle your data. So Spring allows and gives you these features which supports the working with databases like SQL, Oracle, etc. Such examples of ORM framework which offers complete integration with Spring is Hibernate, JPA, JDBC 10. Next is transaction management. Spring provides you and allows you to write the transactions without writing the low level code. So if you must have seen in many of your projects that you have written transactional over a method or over a class. What does that mean? It means that you are capable enough to make sure that until the whole method is not completed or the whole class execution is not completed, your changes are not committed to database tables. That's transactional for you given by Spring. So transactional management is a beautiful feature given by Spring to you. You do not have to explicitly write commit, rollback. All these things it is internally done by Spring for you. Then it gives you Spring security for authentication and authorizations to prevent you against vulnerabilities. Then it gives you the feature of Spring integration. Now Spring integration is a way through which you can communicate between multiple Spring applications through messages and events. It's basically asynchronous communication to facilitate event-driven architecture. Next is Spring Cloud. Spring Cloud provides you loads of features and libraries for building distributed system, microservice-based applications, service discovery, circuit breakers and many more. So Spring internally provides you support for many of such patterns that you can implement in your microservices to make it a distributed application capable enough to be deployed on the cloud. The last two are important ones, the testing and internalization and localization. Since you are writing an enterprise level code, you must have the way to integrate your code with JUnits, test cases, integration test cases like BDDs. So Spring provides you features which makes your code easily testable with JUnits and integration tests like BDDs. Also, Spring provides you the support for handling the internationalization and localization to create an application that supports multiple languages for multiple regions. So these were very high level features of Spring. You must have used these features in your daily life. Even if you are coding with Spring Boot application, then also you must have used these because internally Spring Boot uses Spring. Next, how would you manage the memory leakage in your Java application? So let's first understand what is memory leak. Memory leak is a situation when a garbage collector does not recognize the unused object, and since garbage collector is not able to find that yes, this is not being referenced anywhere, this is not usable, they still remains in the memory indefinitely, which actually reduces the memory allocated for the application, and hence you keep on getting the out of memory exception or error. So what is the real reason behind the memory leak? The real reason is unused objects still remaining in the memory, because garbage collector is an impression that it is useful, but actually it is not. It is just occupying your memory for no reasons. Now, how would you find that yes, your application is going through the memory leakage? So the symptoms for the memory leakage is the performance of your application decreases a lot and keeps on consistently decreasing, because more and more such objects takes up this space, and application gets less amount of heap and space, and hence it slows down, and hence the performance decreases. Also, you can monitor the usage of memory during the lifespan of the application. You can see that the usage is continuously increasing because you keep on creating objects which are unused and garbage collected. What can be the main reasons for this memory leakage? The main reasons can be the unwanted object still getting references, still having the references. So when you don't need an object, but still the reference still exists, then garbage collector cannot differentiate between the useful objects and not useful objects still having references. So what the garbage collector will do is, it will not garbage collect the objects which are still referenced, though they are not useful for your application. Garbage collector won't be able to distinguish between both of them. So garbage collector fails to reclaim the memory from them, since you are still referring to the unwanted objects, and hence will cause the memory leak. So it is your task to remove the references once you are done with your object, so that garbage collector has the indication that yes, this is not useful. Secondly, long-lived static objects. The static objects also leads to memory leak because they live in the memory for the entire lifespan of the application. So you are using it once, creating it for once, but it is in the memory for a very long time because it is static in nature, and the lifespan of this object is to the whole application's lifespan. So stop using static unless it is really useful. Third, but not so usually a reason in the Spring application, is that you might have some resources created by native systems. Now, what are native systems? Native systems are the older systems. Like for example, if you have some code written in C, C++, JNI and all those things, they might have created some resources and they are being called externally by your Java application, just for the seamless integration between multiple systems. Then the resources created by those native systems will not be able to be garbage collected by Java because it doesn't come under the umbrella of garbage collector. Garbage collector only understands the objects created by Java. They do not understand the resources created by C, C++ and all. So when you fail to clean up those native resources which are embedded in your Java code by calling the external functions, in that scenario also you have memory leaks. So again, it is your task to clean up your native objects. Now the main part, how do you prevent and manage the memory leak? So first of all, do not create unnecessary objects. Do not keep references to objects who are actually not necessary. Avoid string concatenation. Why? Because every time you do the string concatenation, a new object is created. Why? Because string is immutable. Avoid doing that. Better use string builder, string buffer so that they are mutable enough. They do not keep on creating new objects every time you create another string concatenations. Also, the session should be removed as soon as you are done, because the session objects are also staying in the memory for a long time. So whenever you are done, kill the session. Do not use and depend upon garbage collection for system.gc method, because system.gc method is just a way to plead before garbage collected that please garbage collect my objects. But it is not a surety that garbage collector will come into life and will garbage collect your objects. It will not. Only if it is available, its daemon sets are free, then only you are able to garbage collect your unused object. So do not depend upon system.gc types of methods to call the garbage collect explicitly. Also avoid using the static objects. I've told you why. Because the entire lifespan of application, they stay in the memory. So either you reference it to null explicitly or do not use it at all. Then you have a finally block where you can always close your result set, statements, connection object so that no explicit connections are there if the task is done. Also with the newer Java versions, you have try with resources. What makes sure is that whatever you create in the try with resources, even if you don't close it in finally block, it ensures the proper cleanup and removes all the extra connections and result sets and statements. Everything that you have created once the method execution is done. So as to prevent any open connections which will take up your memory. Also, how will you manage and look after your memory leaks? So we have multiple ways to look into the memory leakage. So you have to regularly monitor your memory usage using tools like Java Visual VM, JConsole, and many third-party monitoring solutions are there. So it will help you detect the abnormal memory consumption and identify the possible memory leaks. So suppose if your memory usage is continuously increasing, the graph is always ascending, that means there is memory leak. Also you have profiling tools like YourKit, Visual VM, Java Flight Recorder, which will help you identify the memory leaks by showing the graphs and allocation traces. And the best part is you analyze the heap dumps. So from where the memory is allocated? From the heap. So heap dump is the way to suspect the best memory leak possible. So if there is a memory leakage, generate the heap dumps, analyze them using Eclipse Analyzer or MAT. It gives you the best insight into memory usage and help you pinpoint the source of leakage also. So it can give you the exact location that in this class you are having the loads of memory usage and that is increasing day by day. That means there must be some variables that is getting created in that class which is actually not getting garbage collected and is giving you out of memory exception now and then. So heap dumps are the best way to do that. Now third, explain the internal working of concurrent hash map. So first of all, why concurrent hash map? Concurrent hash map is a class provided by Java Collection Framework which offers you the high performance, thread safe alternative to hash map for concurrent access scenarios. Now what will happen is that when multiple threads try to access hash map, since hash map is not thread safe, it will give you abnormal results on the multi-threading situations and high performance multiple requests coming, your code will break. To prevent the code breakage and to prevent the synchronized access to map, you have concurrent hash map. It is thread safe, it is better in performance, so it's better than hash map as well as synchronized hash map or the hash table. Since it is thread safe, it will allow multiple threads to read and write concurrently without any synchronization needed. And it is achieved through the following internal working. So let's see the internal working. You will be understanding how it is thread safe and how it is, even being the thread safe, it is better in performance. How it is achieving that, we will be seeing with the internal working. So first, I will show you the diagram here. This is a concurrent hash map, okay? So normal hash map is just divided in buckets. So this solid lines would have been buckets for normal hash map. But with concurrent hash map, you have segments and buckets. So your whole concurrent hash map is divided here in our case in 4 segments. And each segment has 3 buckets. 0, 1, 2, 0, 1, 2 and so on. So 0, 1, 2, 3 are the segments, 4 segments. And 0, 1, 2 are the 3 buckets in each segment. So total 3 into 4, 12 buckets you have where you can put your data. So that is how the concurrent hash map is divided physically. So what is segments? The concurrent hash map is divided into segments which are separate hash tables. Each segment is effective in a separate map and with its own lock. So each segment that you see here is having its own lock. Whenever you want to write over a particular segment, you need to first get the lock, write over it, leave the lock. and till the time it is having the lock, no other thread can write or read over it, since it is having the lock. So that's how I can say that the complete concurrent hash map is small hash tables, where each small hash table is called a segment. Now what happens by doing this? It reduces the chances of multiple threading trying to concurrently access the same hash table and increases the performance. So what happens is, now since you are taking a lock only on one segment, all the three segments are allowed to be used. In hash table, what would have been the case? The complete lock would have taken and you have to wait for the whole hash table to be unlocked before reading or writing. But in this case, only the 3 bucket sized hash table is locked, rest all is open for you to read or write. And hence the performance increases, still being the thread safety there. Because one thread is writing here, you are safe to read or write from another 3 because none of this is changing. Hence it is thread safe. Also it is high in performance because you still have another threads working on another segments, which is not possible in normal hash table. Now hashing and indexing. When you insert a key value pair in a concurrent hash map, the hash code is used to determine the segment. Now as usual, similar to a map, concurrent hash map also have 2 things, get and put. Let's see the put operation first. Now suppose I have 1 comma code as my object to be put in the concurrent hash map. How would you do that? Okay, one thing to note, this is concurrent hash map, this is not hash map. Okay, so coming back, how will you decide this 1 comma code is going to be at segment 0 and bucket number 1? So 2 things you need to decide, the segment number and the bucket number inside that segment. Because this bucket number is also present in segment 1, segment 2 and segment 3. So first of all, you will calculate the segment and then you will calculate the bucket inside the segment where that has to be put. So first, you calculate the hash code of the key. As soon as you calculate the hash code, it will decide the segment where it should be placed. And it is usually defined by a math operator and the operation is applied to 2 things, that is the hash of the key and number of segment minus 1. So here the hash is suppose 1 and the number of segment minus 1. So total number of segment was 4, so 4 minus 1, 3. So 1 and 3, you will get something that will be the segment number. Now once you have the segment number, using the same hash code, you will calculate the bucket number also. And when you have both the segment number and the bucket number, you will have the exact location where you have to put your key value pair. So this is one step extra you have to do in normal hash map. Then the normal hash map. In normal hash map, what you used to do? You just calculate the hash code, you calculate the bucket, put the value there. Here you have to calculate the hash code. Now you have to calculate the segment number. Then you have to calculate the bucket number and then you will be able to put your data in the bucket. So one extra step is there in concurrent hash map. But with that one extra step, what you get is thread safety and concurrency. Also with the high performance. Next, segment lock. So whenever you put something on the segment or write something on the segment, you first have to fetch the lock for that particular segment. So what will happen when you are going to write something? It gives you fine-grained concurrency control. When thread wants to perform an operation of write, it only acquires the lock for the relevant segment and thus prevents the whole concurrent hash map lock or the global lock. Now each segment contains its own hash table. I already told you, each segment on its own is a hash table or the array of buckets to store the key value pair. So there will be multiple buckets in each segment. Now each bucket array is very similar to hash map with linked list or tree creations to avoid the collisions. Now here I have an example for you for collision. Suppose my hash function is percentile 10. So 1 percentile 10 is 1, 11 percentile 10 is also 1. Here there is a collision. Now the question is, how will you handle the collision? So it is very similar to how you handle collision in hash maps. What you do, if it is to the threshold, you create a linked list. When it increases the threshold, you create a tree out of it, so that the retrieval is quicker. That is an enhancement done with Java version 8, with Java version. So that is the same thing that is also implemented In concurrent hash map also, so whenever you have a collision, initially the linked list will be created, and when the threshold increases, the tree is created. This was all about the put operation or the write operation. Whenever you want to write anything to the concurrent hash map, what you will do? You will calculate the hash code of the key, fetch the segment number, fetch the bucket number, go and place it in the bucket. If it is collision, create either the linked list, or if the threshold is reached, create the tree. But before doing all this thing, the first step you need to do is to take a lock on the whole segment. Do not write anything on the segment without taking any lock. That's the basic rule. Once you have the lock, go ahead, write over it. But all the 3 buckets in the whole segment will be locked. Remember this. Now when it comes to read, it is fairly simple. Read doesn't need any lock. Unless it is already logged, you can read over it. So since I'm writing over the segment 0, you cannot read from it. But segment 1, 2 and 3 is open for you to read. If you want to read from any of these segments, go ahead, have fun. So the read operation can be performed concurrently without having any lock condition. Unless there is no ongoing write operation on the segment. So that's why if the thread 1 is reading on 2, thread 2 can also read from segment 2. Doesn't mean thread 1 and thread 2 cannot read from the same segment. It does not need the lock. They don't need a lock at all. But if the lock is already taken by some thread to write over it, then you cannot read over it because the lock is taken. So if no ongoing write operation is there, go ahead and read concurrently with multiple threads, no problem, and hence it increases the performance without blocking each other. While the write operation requires acquiring the lock, however, since segments are independent, threads which is operating on different segments can perform write operations concurrently without blocking each other. Also, if you can see there are 4 segments, so how many concurrent threads you can think can work together? So total of 4 threads can simultaneously work together concurrently, each achieving the lock for each segment. Thread 0, segment 0, segment 1, segment 2 and segment 3. But remember, no 2 threads can simultaneously work on the same segment because the first thread will always take the lock and will write over it. So second thread has to wait for the segment 0 then. But only the segment lock will be taken. Not in the case as in the hash table, the whole hash table is logged. That will not be the case in concurrent hash. So that much is clear. You again have resizing and rehashing. That is again same as what you have in the hash map. If the load factor reaches or exceeds the threshold, then resizing occurs and additional extra segments and buckets are added. And this is done independently for each segment. Also, concurrent hash map provides you the weakly consistent iterators, means that the iterator may not reflect the latest changes made to the map. This is the trade-off done to avoid blocking the entire map during iteration. So when you iterate over a map, a weak iterator is there, and the trade-off is that at least you will not log the whole concurrent hash map while iterating. So you might have some stale data, but you will have a better performance. Similarly, memory ordering, since iterator works with the compare and swap technique, you can make sure that across the multiple threads, proper ordering is maintained by comparing the current update with the most recent update and swapping it as and when required. So basically, the concurrent hash map achieves concurrency by dividing the whole map into segments, allowing multiple threads to simultaneously work, and hence it gives you more concurrency and better performance. Now the next question, can we use lambda expression without functional interface? Answer is no. You cannot use the lambda expression, which is a part of Java 8 new features, without the functional interface. Why? Because lambda expressions are closely tied to functional interfaces. Now, first of all, let's understand what are functional interfaces. Functional interfaces are those interfaces with exactly one abstract method, that is single abstract method. Now, lambda expression provides a way to implement that abstract method. So, lambda expression is an implementation of that abstract method. So, unless you do not have a functional interface with a single abstract method, to whom will you give the implementation to, right? So, lambda expressions are designed to simplify the process of implementing the functional interface. Now, I'll give you an example of runnable interface, okay? It has one abstract method run. To implement that, either you create a class implementing runable, override the run method, or you create a lambda expression. So if you do not have functional interface, to whom will you provide the implementation? First have a problem, then have a solution, right? So if you don't have functional interface, there is no implementation required for any method. So this was a tricky question. You must have your basics clear that lambda expression is actually an implementation of abstract method of a functional interface. If there is no functional interface, to whom will you provide the implementation to? Thus, lambda expression should not be used without functional interface. Now, if you have a situation where you want to have lambda-like expressions, but no functional interface is there, you can use a method references. But again, I'll say method reference is a complete another feature of Java 8. It is used to refer to a method of a class using the two colons, that is a method reference. But in real case, if you do not have functional interface at all and you just need to refer to a method, go for the method references. But again, the question was, can you use lambda expression without functional interface? Answer is no. Now a very important question from the microservices perspective. You must have implemented microservices in your project to make your journey to the cloud. Now, how will you handle distributed transactions in microservices? Handling the distributed transactions can be complex due to decentralized nature of services. Now, you will have multiple services, okay? Suppose you have a food delivery application. One is the order service, one is a payment service. Now, if you place an order, you will take a payment. But if payment fails, you should cancel the order. How will you manage the transaction between these two microservices? These two are separate microservices with completely separate databases and everything is separate. So how will you do that? One solution you might say to me is that we can use two-phase commit, 2PC, where in the first phase, both the order service and the payment service prepare to commit. And then they together go for the commit. But now what if the payment fails? Then you should have a rollback to order service. But it is not a part of same transaction. Why? Because the transaction exists in a particular application and these two are different applications with a complete two different databases. How will you manage transactions when two different databases? You cannot. So the answer to that is we have multiple options given in microservices design pattern itself. First is the Saga design pattern. The Saga pattern breaks down the complete transaction into series of small local transactions. So one local transaction will be done in order service, one local transaction will be in the payment service, done individually. Now each service is responsible for its own transaction. Order service will do its order transaction, payment service will do the payment transaction. Once order is placed, small event is triggered to the payment to take the payment from the user. If something goes wrong in the payment, a compensating event from payment comes to order service to revert the changes or to cancel the order, because the payment is not done. How can you deliver the order? So a compensating transaction is always needed whenever you have to revert your change. So that is how the transaction is maintained. We have covered the Saga design pattern, the orchestrator and the choreography, everything in the video. If you want, just let me know in the comment section. I'll give the link also. So that is Saga design pattern to handle the distributed transaction. Also, you can have the event-driven architecture where an event helps you to decouple and manage the distributed transactions. Here, the communication is completely asynchronous through events. So what you do is, you do the event creation in the order service, triggers an event to the payment service to make it done. This approach allows you to have the coupling reduced and will help multiple services to participate in the transactions independently. But here also, whenever there is something failure happens, you have to have the compensating transaction to roll back. That is very similar to a synchronous communication. That is also again the event based publish subscriber messaging queue. This is very similar to event driven communication. Next is event sourcing and CQRS. Event sourcing involves storing logs of all the changes done to the system data. This is a separate design pattern and CQRS is a complete separate design pattern. In CQRS, what you do is you segregate the create, update and delete from the get operation. From the CRUD, you have taken the create, update and delete completely separate and the read operation completely separate. That is how you manage your transactions. So one is only responsible for updating your databases, one is responsible only for reading from the databases. Thus manage the distributed transactions, because only one application is responsible for complete updation. You do not have to manage the transactions explicitly for the updation part. So these were some design patterns given by microservices to help you handle your distributed transactions. But in real life, most of the distributed transactions are handled using the Saga. That is the best way to handle your distributed transactions in microservices. Now next is what is JWT tokens. Also we have a complete separate video on JWT created for you. Just for the interview purpose, what is JWT? JWT stands for JSON Web Token. It is a compact, self-contained way to represent information between two parties, typically used for securely transmitting information between client and server. Suppose there is a front-end application, there is a back-end application. Now front-end application is expecting you to create an order, but are you authorized to do that? Are you logged in? So how will you define your authenticity and authorization for it? That is through the JWT tokens. So JWT tokens are used for authentication and authorization scenarios. The JWT is basically a string consisting of three parts: the header, payload and signature. So it's XYZ. Here you can see this is the JWT.io. Here this is X, this is Y and this is Z. So that is header, then we have payload, then we have signature. So that is how the JWT token is created. So header consists of two things: the token type and the algorithm being used. So here this is the algorithm used and the type is JWT. The payload consists of claims. So here you can see there are three types of claims here. That is SUB, name and the time. Name is say John Doe. So these are the claims, that is personal information of the user. So second part contains the payload containing the claims. Claims are the statement about entities or typically the user and their data. The user ID, the user name, all those things becomes the part of claim. Now there are three types of claim: registered, public and private claim. We have already covered all this in an explicit video. If you want me to cover it again, I'll give you the link in the description. The last part is the signature part, which is where you have the encoded header, encoded payload. So base 64 encoding is basically used for encoding your headers, payloads. A secret and algorithm defined in header that signs that. So here you have the HS256 encoding. So with this encoding, this whole signature is encoded. So what it takes is, it takes the header, encoded. It takes the payload, encoded. Then it gives you some secret. It adds all these three things. And the total is actually encoded with what is given here, HS256. So here HS256 is used for your encoding. And this signature is used to give you the authenticity of your JWT token. So JWT is signed with a secret key or with a public-private RSA algorithm. The signature ensures the integrity of your token and allows you to verify the token was not tampered at all. So JWTs are often used in the authentication flows. For example, when the user logs in, server gives you the JWT for user's identity and all the other relevant data in the terms of claims that I have shown you in the payload. The payload has all the claims about the user. So this JWT is then sent by the front end to the resource server or the Tomcat, and then the server or our application, backend application, ensures whether the JWT is properly signed or not. How does it verify the sign? Your Tomcat application will have this secret. It will encode the header, it will encode the payload, it will give the secret and will encrypt it and will see the sign matches. If the sign matches, then you are good. This token is not tampered. If it is not matching, then somebody has tampered with your JWT token. It will give you authentication authorization error. That's how authentication authorization is done for the JWT token. Now, why do we use JWT tokens? Because they are compact, they are easily transmitted in the HTTP headers, the parameters, or within cookies. Usually, we send the HTTP headers with the bearer tokens for these JWT tokens. Now, what kind of information you should put in JWT? Remember, since it is easily decodable, it is just the base 64 encoding that you use. It can be easily decoded with the base 64. So since it is easily decodable, you should avoid using sensitive information such as password, the personal ID numbers in JWT tokens, because they are basically 64 encoded. Anyone can decode and read its content. So this is very important thing. Do not put anything in header and payload and claims which is very sensitive. It will easily be decoded. Next, keep it compact. Means it should be lightweight and compact. It should only have the necessary information because there is a limit to the claims you can add. Else your token will be very heavy. Now, some information which are redundant and can be found from the other sources like database, you can avoid them. Like for example, the user ID can be fetched from the table. Then you just, such as a username can be fetched from the table. You just pass the user ID, all the information can be taken from the database. So avoid redundancy, just pass whatever that is needed. Also include information which is relevant and not needed for a particular interaction. For authentication, you just need the user ID and the roles. You might not need the username. So here the John Doe that we keep here can be also asked as an attribute from the database. So again, remove the unnecessary things, keep it compact and keep only information that is needed for authentication and authorization. Do not keep anything just for sending it. Then we have custom claims. You can also add n number of custom claims, just not what is given by JWT standards. So you can also do that. Now a very important question, how does resource server validates the given JWT token is valid? Does it always have to go to auth server? So suppose Okta is our authentication server, authentication authorization server. Does it always have to go and say, is this token valid? Is this token valid? Answer is no. You can also check it with the expiration time, the signature and additional checks from the claims. So there are 3 ways to check it. So you have a signature, right? Now as a backend application, I will have the secret with me. I will have the header and payload coming in the token. I can encode it in this way, add my secret, encode the whole thing with SHA-256 and validate the signature. If the signature is valid, then the token is not tampered at all. So that's what the backend application must do. First thing. Also, it should also check the validation of expiration check. So you have the expiration time coming in the claims, in the token payload. If the current time is later than the expiration time, then it is invalid and do not allow the person to use that token. It should give you an exception of the token has already expired. So you being the backend application, you have all these tasks to be done by yourself. Do not always go to Okta server and ask, is this token valid? Is this token valid? It will just add the extra networking overhead to your application. So first check the verification of signature on your own. Check the expiration. Also check the claims. Suppose in the claims you have the audience. That is AUD, that is a claim given by JWT to you. So it can perform, your application, backend application can perform the checks on the basis of audience claim to ensure token is intended for your application. Also check all the custom claims in the authorization for the authorization and access control part. So once you are done with this, now you can actually do it on your own. You don't have to depend upon Okta to tell you whether the token generated by Okta is right or not. But still there can be some cases where you might need to go to additionally check whether you are having the most updated token or not. There can be multiple cases. I'm not denying that. So once you do it on your own, that is stateless validation, where the resource server or your backend application independently checks the token signature, independently checks the expiration, independently checks the claim and say that this token is valid. You can go ahead with the resource and take the resource that you need. But in case there might be some occasion where you need to call the authorization server like Okta. In such cases, which is beyond the signature verification and token validation with expiration, in that cases you can have the call to Okta, give the token and tell, am I having the right token? Should I give the resource to the front end? If yes, then that is stateful validation. So it completely depends upon you. What I always prefer is stateless validation because it prevents the network overhead and potential performance reduction. So that was mostly about the questions that is asked in TCS. We have multiple more questions like what is the difference between REST controller, REST, how auth2 works independently. That is always being asked. what is Saga design pattern, what is Zipkin's truth, eventual consistency, and I have many more questions to be covered. So if you want me to cover more such questions, just let me know in the comment section. I'll create the second part of the TCS interview questions only. Thank you.